Okay, hello everyone. Let's get started. I'm Chen from Fukuoka. I'm a front-end engineer. And today's topic is about millisecond matters. And this is a story about waiting. And let's get started. I believe everyone is familiar with this one. When you see this spinner, that means you have to wait for a certain while, and you have no idea how long you have to wait. And waiting is painful. Waiting is unpredictable. So you have to optimize the loading time of your app to improve the user experience. So as a front-end engineer, we have a lot of technologies. We have another approaches to improve the performance. So for example, we have tree shaking to eliminate the unused code. We have code splitting to load those necessary code on demand. And we have service worker to move some heavy loaded work into off main thread. And we can use resource hints to let the browser knows which part of resource is useful. And we can use lazy loading and sort of many other techniques to improve those measurable time. So what I'm going to say is optimize measurable performance is important because those improvement is easily to be measured. You can count on how many seconds you have improved. But this have a big problem is there's come to a $1 million question is what if user didn't notice what you have improved? For example, some research shows that physical difference within 20% or less are imperceptible, which means if you improve for example, the 5-second task into a 4-second, probably user is not going to perceive because humans' body have some sort of limitation that we cannot perceive the difference within 20% or less. So that brings very important issues, how humans senses time. So we can split this kind of issues into two phases. For example, we can split into active phase and passive phase. So that means when we are given a very simple example that active phase means we have a high loaded mental levels for like we are busy working on something. And passive phase simply means we don't have so much time to do without these kind of things. So that means, for example, passive phase is tend to be overestimated by 36%. So, and we have a simple example for that. That is, when you are busy doing something, you have highly mentally loaded mental level, and you probably will not sense the time flies. And when another passive phase example is probably sorry. Passive time means when you don't have certain busy working on your brains, you are not going to left something behind. So what's important is to let users stay active. And the most important things, we have 3 takeaways for keeping user active. First one is to keep user away from passive phase. And if the passive phase is inevitable, we don't tell a user they are waiting, or we can use the waiting fields faster. So the first thing we want to share about is how we do the predictive loading. So for example, we already know the idea of lazy load is to load those kinds of resources on demand. Like we are scrolling on our phone, we cannot we can load some resources on demand when the image is loading on a specific position. And what we can do one step further is to like, for example, we have a certain form, and we have a certain confidence that when users fill in a certain percentage of this form, we can preload the next page, and this page could be loaded on time with when users like fill in 80% of this form, so we can improve the page load speed. And the second one is we want to be inconsistent. Here's some demonstration about being constant is very important. So for example, we have in the left part is something we are not optimized. For example, we have some image loaded and the screen will pop up and let falling down one by the bit. So this kind of thing, this kind of inconsistent will make users feel bad, because this kind of inconsistent will make users feel those kind of website isn't working right. So we can use some new technology like skeleton screens or like a placeholder to make it feels better. And another one is we want to use those loading indicators wisely. For example, those kind of waiting indicators in the first in the first stage we see is sort of like when you see the loading indicator, it feels like you are going to wait for a while and you are not going to do anything. So when your user sees a loading indicator, that means they have to wait, and they don't know how long they should have to wait, so it feels bad. But if we can use this kind of animation wisely, for example, we have some kind of progress bar, and we can use different kind of animation to make the waiting feels better. For example, we can use you can see these three kind of animation having same speed, but with different kinds of animations. But if you can use the animation wisely, for example, you can use the backward spin animation in the second, or accelerated backward acceleration animation. You can let users feel the same speed progress bar feels faster. So this kind of animation will make users feel better when they have to wait. So research also shows progress bar with counter-accelerated animation will make user feel 20% faster. So this kind of thing is what we use to measure perceivable performance. So perceived performance matters because it always based on what measurable performance. And always measurable performance is important, but you can use this kind of tricks to make user feels faster, even if you don't improve those kind of measurable performance. It really like, for example, 20% or more faster, but you can use this kind of trick to manipulate the mental state of the user and make it feels faster, even with this kind of perceivable performance comes into play. So that's about my presentation, and I hope you find this sharing useful. And if you got interested, there are some reference related to this talk, and that's about my talk. Thank you.